just say I'm drawing, let me just draw a tree, because I like drawing trees. And you guys should all get practice drawing trees, because you're going to need to know how to draw them for the exam. So here, you can pick a man or a woman. How many men are there? 8 out of 25. So the probability of picking a man is 8 out of 25. Woman is 17 out of 25. Then for the second one, you can pick either a man or a woman. But if I'm here, folks, I've picked somebody, how many people do I have left to pick from? 24. I had 25, now there's only 24 people. How many of them are men? One less. How many is that? 7 out of 24. Now, if it's without if you replace them, that's what it stays the same. But we're not replacing them, right? The winning ticket is not replaced. The other time when it's kind of like replacement is if we're talking about a giant number of people, like all Californians or all Americans. If I pick somebody of all Americans, that one person does not make a difference. Out of 25 people, if I pick one person, each person represents 4%. They matter. You know what I mean? 1% out of 25 matters. 1% out of 300,000 doesn't matter. I mean, not that they don't matter, but in terms of percentages, statistically, yeah, they don't matter. Okay. All lives matter. Okay, fine. All right. So here, we care about them both being men. So we need to find this spot here, multiply the probabilities. Right, so 5 over 25 times 7 over 24, and you will get 7 over 75, which is 0.0933, I think was what the other classes got, yeah? What's our guideline for unusual or unlikely in statistics? Our general guideline? 5% or less. So this, if you're not sure how to get to percent from here, just think about cents. Where's the cents place? So you guys all know money. What position is the cents in? Right here. So cover up that, and that's roughly 9%. 9 cents, 9%. So 9.33%. You could do it that way. Or, alternatively, you could say that, 5% is like 5 cents, so it's 0.05. And if you don't like comparing decimals like this, just give them the same number of decimal places. This has 4. Make this one have 4, so you compare it better, 500 to 933. And you can see that clearly this is not this or less. So it is not unlikely.
What if we said it was likely but doubtful?
That's fine, but yeah, as long as you get it's technically likely in terms of statistically.
I would think that likely would be 95% or more by the same way, because like
yeah.
It's likely, but you have a 9% chance. That's not a good thing.
Yeah, I mean, well, it's I know it's weird, and it's not what you might use with your friends, but it's what you need to use in terms of statistical analysis.
So it's likely.
Yeah.
Does the news rooms use that kind of stuff?
What was that?
Did newsrooms use that kind of statistics?
I don't know.
Oh, it's likely.
Yeah, I don't know. They do all sorts of weird things, so it's really hard to tell. Yeah.
For the homework, what's the threshold? Because
5% or less.
it wasn't done on the
I don't think it was.
Yeah, there was one. Can you send me that problem, because that's an issue, and it came up. I saw one person who had that same problem last year, and I think most people had not gotten that problem, and a handful of people had gotten that where it wasn't 5%. So send me yours. Email it, like send it, ask my instructor, go to it and do ask my instructor.
Can you go faster than after you've already submitted it?
You can. So here's the deal. If you're going to look at it, pick the, I'm not going to change things, I'm just going to review it. Don't pick the, I'm going to change things. Otherwise it will change your, like if you go, it's fine if you did 1 through 10 and you forgot to do 11 or you couldn't do 11, and you're going back to pick 11, then go ahead and say I'm going to change things and then do 11 and it'll give you 50% on 11. But don't go back through and do number 9 again, because you got 100% on it the first time. If you go back and redo it, you're only going to get 50% on it. Does that, you guys understand what I'm saying? So don't redo ones that are already done. Just redo ones that are not done. That's problem by problem. So if you did part A, then, and you didn't do part B, then you go back, and redo it, you'll get the same grade because you'll get 50% on the whole problem if you get it all right.
I don't think it will show the ones that, because if you redid it, it doesn't go back to the,
Okay.
because I
Yeah.
just got, yeah, I just.
Yeah, I don't know.
do it.
I'm not sure how that works. But if you view, you can view it, and that's fine. It should give you two options for doing that. Okay. But then if you could view it and let me know which one it is, that would be good.
Oh, you mean like the number?
Yeah.
Yeah.
All right. So, did you guys finish this one already? This is problem number 2.
184.
Who's done this one? Is all finished? Okay. So, who needs another minute or two? Okay, looks like we're good to go. All right, so we'll take a look. So we have 3 urns that have red, black balls in it, and then we're saying, what's the first thing that happens? What do we pick first? Urn is selected at random, randomly. So, what are my possibilities? What are my choices? What are my choices, guys? What was that? Yeah, so third of a chance for each urn. So 1, 2, or 3 are my choices. Each have a probability, they're all equally likely, right? I'm randomly picking one. So they're all 1/3 chance.
You're so stupid.
Now, you got to figure out what goes on from there. Red or black balls. Does anybody need just another minute, or are you guys really ready to go? Ready to go? Okay. So here I could pick red or black. What's the probability I pick a red ball? 1 out of 5? 4 out of 5. What about black ball? 1 out of 5. Better add it to 100%. How about if I pick urn 2? Red or black? 3/5 red, 2/5 black. And this one, red or black. And this one is, yep, 3 out of 6 and 3 out of 6. Huh. So we care about these spots here. And so you guys did 1/3 times 4/5, and 1/3 times 3/5, and 1/3 times, I'm going to make this 1/2 because it's just easier number-wise. Now, if someone wanted to, they could have said, let's not go there. Okay. So then you can either add up these fractions, put them in common denominators, or you can use your homework problem is going to want it with 3 decimal places. So you can't just find all the decimals and add them. Here's the thing. If you do it through calculators, round it out to like 5 decimal places. And then add them, and then round to 3 decimal places and put your answer in. Otherwise, you could be off by, your rounding could be off by a little bit. Does everyone understand what I'm saying? So, if you're going to, why am I even saying that? So here's the thing. How I want to find the probability that I get a red one. I could get it by going through urn 1 and getting a red one, urn 2 and getting a red one, or urn 3 and getting a red one. So these are the 3 different ways. So it's this way, or this one, or that one. Or as we add. So we're going to add those 3. Like I said, you can do it with your calculator, find all the decimals, but again, give yourself 5, if you need to round it to 3, go out 5 decimal places and then add it. Yeah?
For the last one, for the duration of 3,
I just shortened up the 3/6 to 1/2.
Okay, so we can do that, that's fine.
Yeah. Well, normally I wouldn't, but because these are not the same denominators, then I'm not going to get the same one anyways.
Okay,
I would have got 18ths, and 18ths and 15ths is a real pain in the butt to work with.
okay.
Whereas 6ths is a little bit easier. So normally I would recommend that you not, because the problems I'm going to give you, they're all going to have the same denominators. So then you wouldn't want to do that, because then you got to like change them back and then add them and then, you know. So, but this is a weird one that your homework gave you. The reason why I gave you this one is because it's in your homework.
Yeah.
So everything on your quiz and those 4 problems that we're going over, they're all in your homework. So, you know, we should go over them now so you guys have them. And then, like I said, you can find all the decimal equivalents for each one of these, but again, give yourself 5 decimals, add them up, and then round to 3 before you put your answer in. I think you end up with, well, I'm just going to do it by fraction because I like that better. 8/30ths, 6/30ths, 5/30ths. So if you add those all up, you'll end up with 1419 over 30, which I think someone said last class was 0.6 something. 633? 633. Good. Perfect. All right. So then the next one, also on your homework. Right, so this one. Let me go back a little bit and give you this. My other class liked this. So here, if you click on something in there, the view an example, it will give you something like this. I think they might actually have numbers instead, like a 5 and a 6 instead of that. But it shows you all the different possible ways. So you have 1, 2, 3, 4, 5, 6 ways of rolling the second dice, and 1, 2, 3, 4, 5, 6 ways of rolling the first dice. So altogether you have 6 times 6, 36 different ways of rolling 2 dice. So how many of them have so first of all, a sum greater than 9? Is 9 greater than 9? No. So you need 10, 11, and 12. Are you guys on board with me? So the ones that are greater than 9 are these 6 here. Right? 10, 10, 10, 11, 11, 12. So these 6 out of how many? 36. And I'm just going to simplify that to 1 over 6 to make my math a little bit easier later on. Okay, so then we'll move on to our actual problem. Here's the hard part about this. The probability of getting a number larger than 9 for the first time on the third roll. If you do something for the first time on the third roll, that means, did you succeed or fail on the first roll? Failed. Did you succeed or fail on the second roll? Failed. Did you succeed or fail on the third roll? Succeed. So it went no, no, yes. Do you guys see what I'm saying? So we had a no, no, yes. So what's the probability of well, the probability of yes is 1/6, right? Which means the probability of no would be, probability of no is 5/6. The complement, right? Either you have a yes or a no. They should add up to 1 or 100%. Good? Okay. So this is no and yes. That's what we're finding the probability of that. So, and we do what? And we, come on guys, and we multiply. Great, thank you. So no, 5/6, and multiply. No, 5/6, and 1/6. So 25 over 216. Good. Which is More than 10%. One, two. What is it, 12%?
Yeah.
What is it exactly? Point
116.
116. Okay, there we go. Good deal. All right.
Would you round that up then to the point 1, 2?
They usually like 3 sig figs or 3 decimal places, so give them that. Yeah, I think it's like 1155 or something like that, 56 or something. Yeah. Okay. Great. Questions on that one? Are you guys gonna be okay on your homework for this one? I'll circle the first time on the third roll. That means it went no, no, yes. Does that help make it? Yes? No? Questions about this? Okay. Oops. Oh, we're done with that. Aha. So here, this is important. Why am I reading? Someone else can read. Janessa, go ahead.
Probability of getting plus 1 is minus 1 minus probability of getting
Probability of
probability of A equals 1 minus probability of
a complement. That's a little C. Okay, keep going.
probability of rolling 2 dice and getting X is 24 is 1 minus probability of no 4.
Yeah, that's good. All right, so thank you. So either I have at least one sibling, or I have no sibling, none siblings. Make sense? Either I have at least $1 in my pocket, or I have none, no dollars. So at least one is a complement of none. So I have either at least 1 4, or I have no 4s. It's a lot easier. You guys remember this from last class? If I roll the dice 3 times, at least 1 4 means I can have 1 4, 2 4s, or 3 4s. And there's 7 different ways of doing that. So I can either find all 7 of those ways, find the probabilities and add them up, or I can just find the probability of no 4s. Because it's really easy. The no's and the alls are simple. There's only one way of getting all yeses and only one way of getting all no's. Right? Yes, 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 or no, no, no. Super easy. So it's easy to find the probability of all no 4s. No, no, no. And subtract from 1. It's a lot easier. So why don't you guys go ahead, now this little refresher, hopefully, work on quiz problem number 1. And we'll also take a break.